Hi, this is an introduction video on how to use the ARMS client. You will need some prerequisite knowledge of ARMS, because we're going to cut this fairly short. So let's look at the ARMS client. This is the first workspace we're going to go through. And on the first tab, it's the value at risk tab. So this is specifically done for the value at risk analysis. So let's start at the beginning. So let's open up a portfolio. So we choose a specific date for the portfolio to load and recalc. And then you get a set of hierarchies and customers, and we will load the trading book. And using the trading book hierarchy, we will then see the portfolio tree. So we're going to load all the positions in this tree. You can choose a subset of the tree to load and analyze, but we're going to analyze all of it. And then we go to the next part. We go to the parameter list on how to calculate, and you have the valuation date, and this will be the date on which the positions are standing when you do the valuation. So this will be today minus 1 business day. And then we have the market data date, and this is the date for which we read the current state of the market. So we're going to value these using quotes and rates on this date. And then we have an optional setting to set an alternate end risk date. And this date will be the last date to use when calibrating the risk. So historical simulation will end on this date. And if you do a covariance matrix, it will also end on the date which you choose as the end risk date. And by choosing an alternate historical date there, you can have a stressed VaR. You're running it for some stressed period, but still using the current valuation. And then we choose a base currency to work with, and we need to choose a value risk model from one of the available ones. We have a linear delta, we have the delta gamma, and we have a Monte-Carlo simulation version and the historic. And we have a filtered historic, which time weights the samples, and we have a weighted historic, which also weights the samples, but in a different way from the filtered. And then we have the ES versions, which are the expected shortfall, where we take the average of the tail. So we can start with the historic. And VaR horizon days, that's 1 for now. That means that we're projecting VaR 1 day forward in the future. And sample horizon days is how many days step we take in days backwards when we do the risk estimation. So if we take 1 day steps backward. If we would choose this to be 2, we can then choose a sample overlapping or not. So you either have overlapping samples or non-overlapping samples. Then we have a confidence interval. We can set this to 99 percentile, and we choose a 250 business day rolling window for the historical simulation. And the rest of the settings are for the other VaR models. We don't care about those right now. And then we can choose how to split the positions by underlying or portfolio or position type. And this is actually optional, so you can have all your position splits that you send in with the positions here. And then we can split by risk factor as well. So we're going to split by the default risk factor types. And then we're ready to calculate. So we will press recalc, and then it's going to start. And now we can see that it's done. We have in the VaR table, we get a position-based VaR. So each of the rows here represent 1 position in the portfolio. So we start out with we have a swap, we have a government bond, a mortgage bond, equity position, a call option on an equity, and so on. So we can see the market values, you can see the weights, the VaR in euros, and the VaR in percentage of the market value, and the contribution. And the contribution is the contribution to the total VaR if you remove the position completely. So if we would remove this position, the total VaR of 130,000 would reduce by 40,000. So this is our definition of the contribution here. And then you can sort this by clicking on the header. That's everything about on the position level, I guess. You have the total VaR here for the portfolio. And then we can see on the splits. So we'll start up here, the split by position type. So you get the same type of information, but grouped by all the positions that belong to this group, the position type interest rate swaps, or the bonds, or the equities. And here, obviously, you can have more than one position to each group. So we have a separation on market value long and market value short. And so you can see the VaR of only the long positions, and then you have also the net figures. And also here you have the contribution. So the same way goes here, that if we would remove the equity option totally, we would actually increase the VaR by 3,000 on the total. And then on the risk type split, we have the risk factor types that we're using. So FX is easy to understand. So if we keep everything but the FX still in the risk factors in the historical simulation, we get a VaR of 63,000 euros on a 99 percentile confidence interval. And if we keep the FX still and move everything else, we have the contribution, then we get 14,000. So if we remove the FX risk from this portfolio, we reduce the total VaR by 14,000. So here we can see the interest rates. A standalone is 100,000 VaR and contributes 36,000 if you remove them. So here you can go through all the different risk factor classifications. So if we would want to see this in some other custom way, like maturity buckets, for instance, we can ask to have this recalculated in maturity bucket nodes, and we can sort on this to see that, well, the spot is contributing the most, all the risk factors that are defined as spot. And this is the VaR tab. So we're going to take a break and go over to the next tab. Okay, so now we have switched to the next tab, which is called the position split tab. And here we can continue our analysis of the portfolio. So we have done the same choices, and we have evaluation date, market data date, and then end date. And so we make the same VaR choices, but we will get this then in a two-dimensional grid. So up here we have a position type split versus a risk factor split. So in each of the cells, we will see the VaR for the 99 percentile for all FX in all bonds. So if we click on this cell, we see all the positions that contribute to this specific VaR number. So by clicking on different cells, you see the contents of that risk. And in this split down here, we have a first and second grouping. So we get the position types on one axis and the portfolios on the other axis, chosen on the secondary split. So we can see all the bonds in the Magnus portfolio, for instance, and then we get the VaR for those. This tab has another feature that I'm going to show you, and it's actually changing what we're calculating. So we can have the PnL instead. So we're going to use the optional definition of the date here, the PnL date. So let's switch this to 2 days back, and we switch the value to PnL. And this means that the contents of each cell is the value change for these positions when the market data goes from 2 days ago to yesterday. And if you apply this to the current market data, so we add the 1 day change to the current market setup, and then we get these P&Ls. And obviously we can switch 5 days back and get a 5-day theoretical P&L for the same positions. And the positions still are based on the valuation date. So we're just looking at pure theoretical P&L using differences in market data. And in the same fashion, you can click on the cells and see where this theoretical P&L comes from. And this is quite a nice feature just to check P&L numbers that change from 1 day to the next. So we're going to go on and have a even further deeper analysis of the historic VaR method in just a second. Okay, we're back, and I've switched to the historic tab of this workspace. And here we can analyze all the VaRs coming from where we use samples as the base for the VaR analysis. So that's the historical simulation and the Monte-Carlo simulation, and all the versions of the historic simulation. You can analyze the P&L samples that we generate. And this tab also has some other features, and I'm going to try to go through these, a couple of these features one at a time. So first of all, we can see that we can load a primary and secondary date. And this means that we can load either having the same date, the same portfolio from the same date, and then do alternate analysis with the valuation market data. Or you can upload 2 different portfolios from 2 different dates. So let's start with having the same, so we have comparability. So we have to load the separate, the hierarchies, and we load the positions, all of them. So now we have 2 identical sets of positions loaded. And as before, we have then the primary settings, the valuation date, market data date, and risk date, and the secondary. And I'm going to keep these the same, and also the VaR settings the same. The euro, the 1-day VaR horizon, sample horizon 1, historic simulation, 99% confidence interval, and then 250 days backwards to do. And then we'll ask for a calculation using these settings. And obviously we're going to have identical values on primary and secondary, since all the settings are identical. And we can see that we have a relative, an absolute VaR, and an expected P&L, which is the difference between these two. And the relative VaR is, then we have the sample mean of the historical samples as the base, and the absolute VaR, then we have the current present value as the mean value around which we take the VaR. And the difference is obviously the expected P&L, the trend of these samples if we average them. And then throughout all the other calculations, we're using the sample mean as our VaR definition. The rel VaR is VaR relative to sample mean. So what do we get here? Well, we get all the dates and all the P&Ls that make up our historical simulation. So first of all, we can then sort on the percentiles, and then we see that we have an average of the P&L sample of the 21st of April 2016 and the 12th of September 2016. And we have about 50-50 of these 2 samples. And this makes up our 99 percentile historical VaR, which comes to 130,000. And then we can see what happened on this date. On the 21st of April, why did we have a 137,000 euro VaR loss, P&L loss? So we click on the date, and then we can see that it loads down here according to what classification we have chosen. So we can see that for this date, The equity related positions moved by -82, the swap by -53, and the bonds by -32. So it's quite an equal mix. And then you can click on a certain position and see how much each individual position moved. So we have a single swap position that moved by 53,000 euros on this date, which contributes to almost half of the total VaR. And then down here you can have the same analysis done, but for the risk factors. So we can see that the interest rates here contribute to 79,000 of these euro losses. And then if you click on those, you get all the risk factors that were involved and the change, the original value and the stressed value and the difference that contributed to this change. And we can see we had an FX gain on this date, for instance, that moved in the other direction. So this is the simple analysis. And if we now want to see what happened if we would have done the valuation with the market data from the day before, we could just switch and see what happens if we move and do the valuation on the day before. But everything else is exactly the same. And then we see that the primary and secondary obviously now differs a bit. Not much, but a little bit. So the base valuation is now done on the day before's data. So now we can sort our values and we can align the samples, and then it sorts both of them. And we can see that it still gives the VaR on the same date. And if we would do the valuation of some much previous date, we will have obviously different result, but it's still not that different. And by playing around with these values here, let's say that we have a stressed period for 10 days ago or 100 days ago, we will do an alternate calculation, and we can now see that our secondary value is higher, and we can see then where such a historical VaR would come from. So here's the original, and here's the secondary, which is now on a different date, which means that we can analyze an alternate date instead and see where is this VaR coming from. And then we can also switch, which is quite nice, to our expected shortfall. So if we switch to expected shortfall, all things else equal, we will get the weights of the tail that we're using in the average of the expected shortfall. So here we can see that we're weighting in these 4 samples to get the expected shortfall. And since we're not using the entire sample of this one, it's weighted only in less than half. If we take the 95 percentile, we will obviously get a broader tail with more samples in it. So we can see what that looks like as well. So now we get all these samples weighted for our expected shortfall in the tail. So this is a good way of analyzing your VaR. There's much more to say, and I will try to get back on this VaR tab with a deeper insight in a different session. Thanks for paying attention. Goodbye.